Hi, and welcome to Section 4 on Chaos Testing with Istio. This section is all about Chaos Monkey tests. I will show you how you can inject faults into your microservice communication channels. We'll be using envoy filters to modify requests and responses, and I will show you how you can perform traffic mirroring. In the first video, we will be talking about injecting HTTP delay faults. As usual, I've prepared this README file for you to guide you through this video. I've summarized the required prerequisites. Make sure you have a running Istio installation on your Kubernetes cluster. Please make sure that you have labeled your namespace correctly so that the sidecar injection is working properly. Also make sure that you've exported the external IP address of your ingress gateway. And then make sure you have applied the following manifests to your Kubernetes cluster. So this first one here will set up all those Kubernetes deployments and Kubernetes services. Make sure you have your Istio gateway configured correctly. Make sure you have the virtual service definition for the Hello Istio deployment and also the destination rule. And the same thing here for the Hello Message virtual service and the Hello Message destination rule. So the first thing we do is we check that everything's running correctly without any delays. So you see here, we currently have 4 pods running and also 4 deployments for Hello Istio version 1 and version 2 and for the Hello Message version 1 and version 2. So we issue an HTTP GET request and see that everything's running. So at the moment, we're hitting the version 1 of the message service and the Hello Istio service. So let's configure a few HTTP delays between those two services. Now, in order to configure an HTTP delay for any traffic, well, we have to modify the virtual service definition of our Hello Message. You see here, it's this piece of YAML. We can specify faults, and we can specify the delay fault. We need to specify a percentage. This basically is the percentage of the traffic the delay fault is applied to. And we specify a fixed delay of 5 seconds in this case. And we also need to specify the route and the destination that fault is applied to. So let's copy this and let's open this file here where we want to add the HTTP delay. So once again, a bit of formatting here, everything's correct like this. Now we save this file and we want to apply this file to our Kubernetes cluster. So let's head over to the console. So we kubectl apply this Hello Message version 1 delay YAML. Everything's configured. Now remember, we configured a fixed delay of 5 seconds. The microservices themselves have a timeout configured of 3 seconds. So the timeout is actually shorter than the delay. So we issue this HTTP GET request. 1, 2, 3. And you see, after 3 seconds, we get back an error message telling us that it could not get the message back from the backend. So this is because the microservice is using a timeout which is shorter than the configured delay. So let's play around with the values. If I say I use a fixed delay of 2 seconds, then I would expect that everything's working because the timeout in the microservice is 3 seconds, the fixed delay is 2 seconds. Again, we apply the modified file, and that should be GET request again, which is here, 1, 2, and you see that slightly longer than 2 seconds, we will get back the message again. So this way, you can make sure that all your microservices have configured proper timeouts in their HTTP clients. So this is what you can use the HTTP delay fault for. So we've checked everything, and maybe as a bonus, play around with those HTTP delay values and also the percentage to see the different behavior.